equation and graph of a circle. Let us have the given circle, and the center has coordinates h and k. Let us have another point on the circle. Let's say this is point A with coordinates x and y. And then as we form a line segment joining the two given points, we form a radius denoted by small letter r. Now finding the distance or the length of this given radius, we use the distance formula. So again, that is the square root of quantity x sub 2 minus x sub 1 quantity squared plus quantity y sub 2 minus y sub 1 quantity squared. By substitution, we'll have, for our x sub 2, we have the x minus the x sub 1, which is h, and then square, plus our y sub 2 is y, minus the y sub 1, which is k, quantity squared. Squaring this both sides of the equation will form the square of x minus h plus the square of y minus k equals the r squared. And this is basically our standard form of the equation of the circle, or this is also called as the center radius form of the equation of the circle. So again, the standard form of the equation of a circle, if the center is at h, k, will have the square of x minus h plus the square of y minus k equals r squared. For an instance, if our center is at the origin, knowing that the coordinates of the origin are both equal to 0, so as we substitute the value of h, which is 0, and for our k, which is also 0, we'll have our standard form of the equation of a circle whose center is at the origin will be x squared plus y squared is equal to r squared. Let us have an example. Find the equation of the circle whose center is at the origin. Again, we have 0, 0, and whose radius is 3 units long. So we have the given, the center. We have 0, 0, and then our radius is 3 units. And then we use its standard form, which is x squared plus y squared is equal to r squared. We substitute the value of our r, which is 3. So we have x squared plus y squared is equal to 3 squared. And then simplifying 3 squared, that gives us x squared plus y squared is equal to 9. So the equation of the circle whose center is at 0, 0, and whose radius is 3 units long will be x squared plus y squared is equal to 9. How about if we want to sketch the graph of a circle in a Cartesian plane? So first, determine the coordinates of the center and the radius. If the equation of the circle is in the general form, we transform it first to the form square of x minus h plus the square of y minus k is equal to r squared, or the center radius form of the circle. And then we draw the given graph. So from our previous example, we have to remember this first, that if r squared is greater than 0, then the graph of the equation is a circle. And then if we have r squared is equal to 0, then the graph of the equation is a point. And lastly, if r squared is less than 0, then the graph of the equation is a null set, or it has no graph. So again, to draw the graph of the previous example, wherein the center is at the origin, or we have 0, 0, and the radius is 3 units, we have our Cartesian plane. And then we plot first the point C, or the center, which is already at the origin. So here is our origin. So we plot that. And then we have to identify the number of units from the center, which is 3 units. So from the center, so we have 1, 2, 3. And then on the right side, we have 1, 2, 3. And then here we have 1, 2, 3. And also on the left side, we have 1, 2, 3. So again, we have this other points. And then we connect those points, forming the graph of the circle. So this is now the graph of the circle given the center at the origin and the radius 3 units. Another example, let us write the center radius form of the equation of the circle with center at -4, 7 and a radius of 2 units. So again, the given would be the center will have -4, which is our h, and our k will be 7, and the radius, or r, will be equal to 2. So having again the standard form of the equation of the circle, we substitute our given values. So we have x minus our given h is -4 squared plus y minus the given value of k is 7 squared equals our r is 2, then we square it. Simplifying this first, we'll have x minus -4 becomes x plus 4 squared. And then we copy the remaining. We have y minus 7 squared and then 2 squared. That means 2 times 2 is equal to 4. So the center radius form of the equation of the circle with center at -4, 7 and the radius of 2 units will be the square of x plus 4 plus the square of y minus 7 is equal to 4. How about the graph of this given equation? So again, our center is at -4, 7 and the radius is 2 units. So we have again our Cartesian plane. We have to plot first this point C having coordinates -4 and then 7. So our -4 refers to the x coordinate. Our 7 refers to the y coordinate. So since we have negative value of x and a positive value of y, we can locate the center of this given circle here. So it is located now in the second quadrant. So we have -4 and then +7. And then we have the length of the radius, which is 2 units. So from this center, we'll have 2 units. And then we can now form for the graph of the circle. So from this center, we'll just have to count 2 units. So 1, 2. Then from the center, 1, 2, 1, 2, and then 1, 2. So this is already the graph of the given equation. What about the general equation of a circle? So from our given standard form, or the center radius form, the square of x minus h plus the square of y minus k equals r squared, we can get the general form of the equation of the circle. So what are we going to do is to square the given binomials. So we have x squared, or x times x is x squared. And then we have 2 times x times -h is already -2hx, or -2 times h times x. And then -h squared will be +h squared. And then for the other square of binomial, we have y squared. 2 times y times -k is -2ky. And then -k times -k is equal to +k squared. And then we have to combine the r squared to the other side. So we add -r squared both sides. So we have x squared minus 2hx plus h squared plus y squared minus 2ky plus k squared minus r squared equals 0. And then we need to arrange the given terms. So we have x squared plus y squared minus 2hx minus 2ky plus our given h squared plus k squared minus r squared is equal to 0. And then let us say that our d will be equal to negative 2h. And then our e will be equal to negative 2k. And then this given h squared plus k squared minus r squared will be our f. So to find the general form of the equation of the circle, we substitute. We'll have x squared plus y squared. And then we have negative 2h is already our d. So plus d, then we have still x here. So we have plus dx. And then our e again is negative 2k. So this negative 2k becomes e. And then we still have y. So we have plus ey. And then this h squared plus k squared minus r squared is already our f. So therefore, we have x squared plus y squared plus dx plus ey plus f equals 0 as the general form of the equation of the circle, where our d, e, and f are real numbers. So let us have an example. Let us write the general equation of the circle with center at 3, negative 2 and a radius of 5 units. So again, our given, we have our h, which is 3, our k is negative 2, and our r is 5. So given our standard form, we simply first substitute the values. So we have x minus our h, which is 3, and then square, plus y minus our k is negative 2, and then squared, equals the r squared will become 5 squared. Simplifying this one, we'll have x minus 3 squared plus, this one is y minus negative 2 becomes y plus 2, then squared, equals 5 times 5 is equal to 25. Now since we are required to write this into general equation of the circle, we need to square the given binomials. So first we have x raised to 2 is x squared, and then we have 2 times x is 2x times negative 3 is negative 6x. Then negative 3 times negative 3 is positive 9. And then we have here y squared, and then 2 times y is 2y times 2 is 4y. Then 2 times 2 is equal to 4, equals 25. And then we arrange the terms again. So we have x squared plus y squared minus 6x plus 4y plus 9 plus 4. And then we have positive 25 here. We have to add negative 25 both sides. So we have negative or minus 25 equals 0. And then we simplify our constant values here. So we have x squared plus y squared minus 6x plus 4y. 9 plus 4 is 13, and then 13 minus 25 is equal to negative 12, equals 0. So therefore, the general equation of the circle with the center at 3, negative 2 and a radius of 5 units will be x squared plus y squared minus 6x plus 4y minus 12 equals 0. So let us have another solution. So knowing that we have the general form of the equation of the circle, x squared plus y squared plus dx plus ey plus f equals 0, and we have said a while ago that our d is equal to negative 2h, our e is equal to negative 2k, and our f will be equal to h squared plus k squared minus r squared. So we can substitute the value of h here, which is positive 3, our k, which is negative 2, and of course the same thing with our h and k here, which are 3 and negative 2 respectively, and our r, which is 5. So by doing that, let's have first our d. So we have d equals negative 2 times h, which is 3. Negative 2 times 3 is negative 6. And then for our e, we have negative 2k, so negative 2 times the k is negative 2 also. So negative 2 times negative 2 is positive 4. And for our f, we have h squared plus k squared minus r squared. Our h is 3, so we have 3 squared. Our k is -2, so -2 squared minus our r, which is 5, and then square. So 3 squared is 9, -2 squared is +4, minus 5 squared is 25. And then simplifying this again, we have 9 plus 4 is 13, minus 25 is equal to -12. So therefore, the values of D, E, and F are -6, +4, and -12 respectively. And then we just substitute these values to our general form of the equation of the circle. Doing that, we have x squared plus y squared plus the D is -6, so we have minus 6x plus our E, which is 4, affix our y, plus our F, which is -12, so plus -12 or simply minus 12 equals 0. So again, the general equation of the circle with the center at 3, -2 and a radius of 5 units will be x squared plus y squared minus 6x plus 4y minus 12 equals 0. And then for the graph of this given equation, so our center is at 3, -2 and the radius is 5 units. We have again the Cartesian plane. We plot our given center, which is 3, positive value of x, and then a negative value of y. So therefore, this is found in the 4th quadrant. So we have here +3, -2, and then we'll count again 5 units. So we have from this center, we have 1, 2, then 5 units, sorry. We have 1, 2, 3, 4, 5. Same thing with the other side. So we'll get the given graph of the circle. So we'll have 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And lastly, we'll have 1, 2, 3, 4, 5. So this is now the graph of the given equation of the circle. Another example. Let us find the equation in general form of the circle whose center is at 0, 3 and passing through the point A, -2, 1. So as you have noticed, we don't have yet the length of the radius, but instead we have 2 given points. So what are we going to do given the center and our point A? In finding the radius, will be using the distance formula. So we'll have D equals the square root of x sub 2 minus x sub 1 plus the square of y sub 2 minus y sub 1. So we substitute the values of the x and y coordinates. So we have -2 minus 0 squared plus 1 minus 3 squared, then getting its square root. So simplifying this first, -2 minus 0 is -2 squared, and 1 minus 3 is -2 squared. And then -2 squared plus -2 squared, that would be 4 plus 4 is equal to square root of 8. Or the square root of 8, we have 8. The factors are 4 and 2, wherein our 4 is a perfect square. So we take the square root of 4, that becomes 2. And then we still have another 2 inside the radical sign. So it could be square root of 8 or 2 times the square root of 2 units. And then this distance is already the length of the radius. As we have solved our radius, which is equal to 2 times the square root of 2 or square root of 8, and the center given is 0, 3, we can now find for the general form of the equation of the circle. So again, we use the center radius form, and then we substitute the values. So our h becomes 0, our k is -3, and then our radius is 2 square root of 2. So simplifying this, x minus 0 is already x, and then square of that is x squared. And then we have the square of this binomial. Y times y is y squared. 2 times y is 2y times negative 3 is negative 6y. And then negative 3 times negative 3 is positive 9. And then for 2 times square root of 2 squared, we distribute our squared. So 2 times 2 is 4. And then for square root of 2 squared, the square root will be cancelled, or this radical sign will be cancelled. So we'll still have times 2. And then we simplify it more. We'll have x squared plus y squared minus 6y plus 9. And then 4 times 2 is equal to 8. Then we combine our given constant terms. So we have x squared plus y squared minus 6y plus 9. We add negative 8 both sides to eliminate this 8. So we have plus 9 minus 8 equals 0. So therefore, we have here x squared plus y squared minus 6y, then 9 minus 8 is equal to 1 equals 0. So the equation in general form of the circle whose center is at 0, 3 and passing through point A, negative 2, 1 will be x squared plus y squared minus 6y plus 1 equals 0. Let's have another example. Let us write the general equation of the circle with the endpoints of the diameter 10, 12 and negative 4, negative 8. So our given here is already a diameter. So we need to find first our center and of course the length of the radius. Now since the given is the diameter or the endpoints of the diameter given these 2 points, we can identify the center of this line segment or diameter by using the midpoint formula. So again, let us say the first point is point A and the second point is point B. So using our midpoint formula, which is x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2, let us identify the coordinates of the center. So we have 10 plus negative 4 over 2 and our y sub 1 is 12 plus the y sub 2 negative 8 over 2. And then 10 plus negative 4 is positive 6 divided by 2 is equal to 3. And 12 plus negative 8 is equal to 4 divided by 2 is equal to 2. So we have already the midpoint with coordinates 3, 2, which is already the center. So therefore, this 3 is our H, our 2 is the K, or this one will be the coordinates of the center. So given the center that we have formed, which is 3, 2, let us now find for our radius. So since we have 2 given endpoints, let us try to use first 10, 12 to identify the length. So the given are the one of the endpoints and the center. So we can use again the distance formula in identifying the radius. So by substitution, we have 3 minus 10 quantity squared plus 2 minus 12 quantity squared and then getting the square root. So 3 minus 10 is negative 7. So we have negative 7 squared. And then 2 minus 12 is negative 10. So negative 10 squared. So we'll have here the square root of negative 7 squared plus negative 10 squared. Negative 7 squared is already positive 49 and negative 10 squared is already 100. So we have 49 plus 100 will be square root of 149 units. So the distance between these two given points will be square root of 149 units, which is actually the length of the radius. Now let us try to use the second endpoint, which is negative 4, negative 8 with the center 3, 2 to identify the length of the radius. So given again our point B, which is negative 4, negative 8, and the center is 3, 2. Let's identify the radius using again the distance formula. By substitution, we have 3 minus negative 4 quantity squared plus 2 minus negative 8 quantity squared, and then we take the square root. Simplifying this, 3 minus negative 4 becomes 3 plus 4. That becomes 7. So we have 7 squared. And then the other part, we have 2 minus negative 8. It becomes plus. So 2 plus 8 will become 10. So that is 10 squared. So we have again the square root of 7 squared plus 10 squared. And then 7 squared again is 49 and 10 squared is 100. Getting the sum will get the square root of 149 units. And again, we have obtained the same answer for the distance or the length of the radius. So we have already found out the values of h and k, or the coordinates of the center, and the length of the radius. We can now identify the general equation of the circle. So using the center radius form, we have to substitute the values. Our h is 3, our k is 2. So we have the square of x minus 3 plus the square of y minus 2 equals r squared. Our r is square root of 149, and then we square it. And then we simplify this. So we'll have the square of binomials. We have x times x is x squared, 2 times x is 2x, times negative 3 is negative 6x. Negative 3 times negative 3 is positive 9. Then y squared is y squared, then 2 times y is 2y, times negative 2 is negative 4y. Then negative 2 times negative 2 is positive 4. And then for the square of the square root of 149, it will now be cancelled, so the remaining number would be 149. And then we arrange the terms, we combine terms. So we have x squared plus y squared minus 6x minus 4y plus 9 plus 4. Since we have 149, we'll add its additive inverse will be negative 149. So we have 9 plus 4 minus 149 equals 0. And then we simplify this. 9 plus 4 is 13 minus 149 is equal to negative 136. So therefore, the general equation of the circle with the endpoints of the diameter 10, 12 and negative 4, negative 8 will be x squared plus y squared minus 6x minus 4y minus 136 is equal to 0. How about if we're going to find the center and the radius of a circle given the equation? So first, we write the equation in the center radius form, or the standard form of the equation. That is, the square of x minus h plus the square of y minus k equals r squared. And then we rearrange the terms and then complete the square by adding to both sides of the equation the square of 1/2 the coefficient of x and the square of 1/2 the coefficient of y. So we'll just be recalling the process of completing the square. And then lastly, we factor the left side of the equation and then determine the center, or the h and k, and the radius of the circle. Let us have an example. Let us find the center and the radius of the circle with the equation x squared plus y squared equals 144. So since the given here is a standard form, or the center radius form of the equation of the circle with the center at the origin, so we can identify it simply by having that the h is already 0 and the y is already 0 also, and then we have 144 will be equal to 12 squared. So the center will be 0, 0 because your h is 0 and your k is also 0, and then the r will be 12 units. So the center and radius of the circle given this equation will be 0, 0 and 12 units. How about if we're going to find the center and the radius of the circle with the equation the square of x plus 1 plus the square of y minus 3 equals 16. So given again, we take our standard form, that is the square of x minus h plus the square of y minus k equals r squared. So in this case, we'll have the value of h, which is negative 1, and for the value of our k, which is equal to positive 3. And then for the 16, it becomes 4 squared. So again, our h is negative 1, our k is positive 3, and our r is 4. So the center is at negative 1, 3, and the length of the radius will be 4 units. How about if we need to find the center and radius of the circle with the equation expressed in the general form? That is x squared plus y squared minus 6x minus 4y plus 12 equals 0. So again, our given, we have to do the completing the square. So what are we going to do is, we confine first the terms with the variable x. So we have x squared minus 6x, then y squared minus 4y, and our positive 12 will be move on the other side, or we'll add negative 12 both sides. So we have negative 12. And then we have to complete the given square. So what are we going to do is to take the half of this negative 6, or the middle term, and then square it. So the half of negative 6, or negative 6 divided by 2 is negative 3. And the square of negative 3 is positive 9. So we add positive 9 here. And remember, what we're doing on one side of the equation will be done on the other side. So we'll add also positive 9 on the other side. And then for our y value, we have y squared minus 4y. The half of negative 4 is negative 2. And the square of negative 2 is positive 4. And then we'll add also to the other side positive 4. So we have here again x squared minus 6x plus 9 plus y squared minus 4y plus 4 equals negative 12 plus 9 plus 4. As you have noticed, we form here a perfect square trinomial. So to factor this, we need to get the square of the given. We need to take the square root of x squared, the square root of 9, and then we affix the sign of this, because our perfect square trinomial will be equal to the square of binomial. So the square root of x squared is x, the square root of 9 is 3, and then we affix negative. And then on this one, we have the square root of y squared is y, square root of 4 is 2, and then we affix negative again. So again, we have x minus 3 squared plus y minus 2 squared. And then on the other side, we'll simply simplify this. So negative 12 plus 9 plus 4 will be equal to positive 1. So therefore, we'll get already the center, or the values of h and k, and of course the radius, given this standard form. So we'll have the value of h, which is 3, the value of k, which is 2, and then for our r, since we have here 1, so the square root of 1 is also 1. So we have the center, which is at 3, 2, and the radius with 1 unit. Let us have another solution. Knowing again that our d is equal to negative 2h, we can use the formula of h equals d over negative 2. Then for our e, we have negative 2k. We can take for our k, which is equal to e over negative 2. And lastly, if we have f, which is equal to h squared plus k squared minus r squared, we can find for our r, which is equal to the square root of h squared plus k squared minus f. So using the said formulas, let us find for h, for our k, and our r. So first we have the h, so we have d. So this one is dx plus ey plus f. So our d refers to negative 6. Negative 6 divided by negative 2 is positive 3. And then for our k, we have negative 4. So negative 4 divided by negative 2 is equal to positive 2. And then for our r, we'll have the square root of h squared. So h squared is 3 squared plus the k squared will be 2 squared minus our f, which is positive 12. So 3 squared is 9, 2 squared is 4, so we'll have 9 plus 4 is 13, minus 12 is 1, and getting the square root of 1 is equal to 1. So the radius will be 1, our h and k will be positive 3 and positive 2 respectively. So again, the center will be at 3, 2, and the radius is 1 unit.